Hello, this is Fundamental of Programming course CO1027. In this session, we are going to talk about functions. Now, you may wonder why we wait for so long to reach this session, because we have talked a lot about structure programming before, but maybe most of you know how to write a function. And why do we need to wait until this moment? Well, there is a lot of concept in function that require you to learn about pointer first, and then now when you come to function, you understand more about what you can do with functions. Okay, mm, everything we are going to discuss here will be a little bit advanced, so I hope you get it. And you may want to take note, and then I will answer all of your questions on the class. Just take note during the session. Okay, now for this session we are going to talk about some issues of function first. Well, the first thing you may note that function is a way to organize your code, and it is provide a lot of advantage over the traditional way. Now think about a program where you have to write like 1,000 line of code inside main function, or sometimes you even get a very big software up to millions of code line of code, and then you cannot pack them all in main function. Okay, that's very terrible thing to do. And you may struggling a little bit with some debugging issues. I think this one is very important. When you have a big chunk of code, it's very hard for you to debug, and of course it is extremely hard to write correctly. Sometimes it's just really tough to manage that 1,000 line of code, not even say about million line of code. Okay, now when you want to extend your software, it's even get harder and harder. You get out of control, you cannot do that. Okay, so this reason is one of the biggest reason why you should not write monolithic code. Okay, and well, it's hard to maintain, of course, when the user, your client, asks for some extra feature or modify something. It may eventually affect the whole set of code you wrote before, and this is terrible because you don't have time to revise all the code. It takes like 1,000 years to do so. You rather destroy them all and then write everything from scratch again. So it is better for you to know you can reuse your code in some sense. Okay, so our function is a way for us to reuse our code. Now talk about functions. You may heard about some concept that we have learned before in mathematics or in some other, well, like physics or chemical, whatever. It's some kind of mapping from the input to the output. So function is going to perform some kind of calculation on the input to produce the output you want. Okay, that's how it works. Now in C++ and in programming language in general, you are going to define the function in some sense, and it can be a procedure where you may take some input or you may take no input. You may want to produce some output, or you may not produce any output, but you take some effect after finish the function. Okay, so that's the meaning of functions in programming language in general. Now for C++, usually we are going to divide your function into two definitions. One is the code declarations. Okay, you have to declare your functions to let the compiler know that there exists that functions. so it can use the function, it can call the function. But beware that this declaration does not mean that you have to write the detail of your function. No, not yet. The detail of your function should be written in the definition. Okay, so to clarify, what I'm saying here is you need two things. One, declaration to tell the compiler no that you have that functions, and the other is the real definition, the implementations of your function. Okay, tell the compiler how to do it. Okay, so here we go. This is the function declaration. Sometimes I use the prototype a lot, because prototype is the very common terminology for this declarations. A prototype of a function include the function name, of course, okay, a list of parameters, okay, and the return data type, right? And it end up with this semicolons. It means, okay, I have the function with the following parameters, and then I'm going to return some data for you. Okay, for definitions, it's also similar, except that instead of the semicolon at the end, you are going to implement your body of the function in this bracket. Okay, now as simple as it looks like, there are several problems and issues inside these function definitions. Let me tell you. You may see here, in the language, it lets you to declare a function with parameters, but it's not required. The parameter is not required means you may have no parameters in the function declaration and in the implementation also. You may want to return some value for your function, but you can also ignore it. I mean, you don't want to return anything, that's just fine. Okay, it's also not required. And you can modify some parameters inside your function, yes, of course, and we will talk about that part in just a moment. Now, well, the first thing you want to look at is a function with no return and no parameters at all, like the display message function I have here. It takes no parameters here, and it returns the data type void. Now you can say, in another way, you can write this way: void display message void also. Now sometimes people tend to write this way because this implies I take no arguments in the middle, but for most of case I just left it empty, and that's reasonable also. So it's up to you. It depends on your coding convention. Okay, now you can write down the implementations of your function here. Now when you look at the code, what happens is your code will be compiled from the top to the bottom. So here, when it combines this line, the compiler knows that there exists a function called display message, take no arguments and return nothing. And then here, when you call the functions, then the compiler don't necessary to have the definitions of the function right at the moment. It just preparing the stack and activate the call to that function location. Okay, there's a placeholder for the functions, and the compiler put some instruction to call that function. That's it. But it doesn't need the implementation of your functions at the moment. Now in the linker, in the linking step, the linker will take the definition of your function here. Of course, during the compiling step, this definition is compiled into the code, and in the linking step, the linker actually put the code and jump to this location in order to run that function. Okay, so it may look a little bit complicated for you, but for most of people, you don't care, you just ignore and you keep moving on. Okay, what I want to say here is be aware. In order to use some function, all you need to know is the declaration, but in order to build your program and link them all together, you need the definitions. Okay, so sometimes when we try to organize function into some libraries, this is better for you to, well, put all of your declaration in one place and put all of your implementation in another place. Usually the declaration will be put in the header file, while all of your implementation of the function should be put in some kind of source file. Well, let's say the library.cpp. Okay, so that is how a library with function should be organized. Alright, here is another example that demonstrates a function with parameters. Well, I have here a function named display sum, and it takes in two parameter, integer and return nothing. Okay, well, you may wonder, why don't I have the same definition and declaration? Well, the declaration above say nothing about the parameter's name, but the definition below needs some parameter's name. Well, it's so obvious because you are going to use those kind of parameters inside your function, right? Therefore, you need the name for each parameters. Why in the declaration you don't need, you only need to tell the type of the parameters so that the compiler know how to activate the code right here. Okay, that's what happens. Sometimes you can also write it very clear like this. Okay, sorry, void display sum integer a integer b. This exactly fine. The compiler doesn't care about a or b inside your function declarations. It doesn't matter. It doesn't use this declaration. Okay, but it may be useful for the, well, it may be useful for the IE you are using. For example, in my case, sometimes when I type out the name of the function and I open the bracket and then I input some value for my parameters, then the IDE now will be quite smart. It can tell which parameter have which name, and then it gives you a hint on the meaning of those parameters. Okay, that can be useful sometimes, but in general it's not necessary. Okay, well, that is the idea that we wanted to say here. Now when it comes to function with some return value, the two examples you see before, it's called the prototype, it's called procedure in Pascal. If some of you learned Pascal before in high school, then you may get familiar with this concept. Okay, it's procedure. However, if a function must return some value, then it's no longer procedure but a function. Okay, Pascal has another concept called function, right? And so here we go, everything come into one single concept called function in C and C++. Now you can see here the only difference I have is the return type here is integer, and you can see everything look pretty much the same. Well, there's another thing about function implementations called inline functions. Well, sometimes you call your functions a lot of times, and you must understand that when you call a function, there is a cost of calling that function, the overhead of allocating memory, the overhead of copying data, and something else that will slow down your program a little bit. Now if you call that function for a few times, that's fine, but think about you are going to call that function like 1,000 times or even million times, then that may be an issues for your programs. Okay, so here we go. Inline function is a way to let the compiler try to put the body of your function in the place where you call that function, and that may reduce the overhead of calling that functions a little bit, and as a result it can speed up the execution of your programs. Now I hope that clear to you. I don't use inline function quite often, just sometimes, but not quite often in structured programming, because well, for most of case I don't stuck with that problem where I have a small function and I call it million times. It's very hard to find out a good example for that case. Okay, but well, in some special occasion maybe you need it. Okay, now talking about parameters, we have several ways to pass the parameters, but in every programming language they may try to restrict some method passing value. Let's say in C and C++, they provide you two ways to pass the parameter. One way is passing value, and the other way is passing using reference. Okay, passing value means the parameters you have in the function actually a local variable inside the function, and when you call that function, the value that you pass in will be copied into that local variable. Okay, by copy I mean whatever you pass the function, stop there, and the function may change a little bit inside to do some calculations, but in the end it doesn't affect something that you pass in. You can pass in a constant, but you can also pass in some variable, but that variable value will be copied into the local variable, and it won't affect anything that you pass in. Okay, now in contrast of passing value, we have another concept called passing reference. By passing reference, it means you are going to have a parameters as a reference, and when you pass a variable inside that location, inside that parameters, they are binding between there's a binding between the parameters, the local variable, and the variable that you pass in, and whatever you do with that parameters will affect your variable outside. Okay, that's reference. And if you remember, if you recall what I have told you about the reference, then you may feel very natural to use reference here. It is very natural. Okay, let's see. I will demonstrate some example here. Here we have the parameters integer as a reference, so the name of your reference is input, and you have reference here, and the type is integer. Okay, so input is a reference to integer data type. Here I have a as 34. Okay, so you get the output here 34, so obvious. Now you call increment a. When you activate the code here, the code will jump into this function and the input here will be initialized as a inside the main, right? And from this moment, input is binded with a. They bind together. So when you perform input plus plus, you actually increase a by 1 unit too. And so you have here 35. Okay, that's easy, right? So keep in mind that when you use reference, you want to use that parameters as input but also an output. Okay, but there is another issue. There is another the reason why we need reference, and I want you to think about it, and I can discuss with you on the class. Okay, now let we talk about array. Well, so far you know what array is, right? And then you may wonder, well, what if I pass in an array into a function? Well, that's kind of annoying, because now there are several ways for you to pass the array into your functions. You can either pass it as the address, I told you so, right? Array is nothing but a constant pointer to some memory slot. Then you may pass that address into a pointer and then use your pointer as array. That's fine. There's two other ways that you may want to do. You may declare array name here and then specify it's similar to an array with the sign here or without sign, whatever. Now all of them end up the same thing. Okay, what actually happens here is array name is nothing more than just a pointer of variable type. They are the same. Okay, now you can do some experiment at home and then tell me what you get, then I will explain to you on the class. It's quite interesting how you work out with array, and from that what you actually pass into the function is not the array. Actually you didn't copy the whole array into a local variable inside your function, but you just copy the pointer address. Okay, here's another example. Well, I have here an array initialized as 33, 66 and 99, and I call the function array as pointer. Okay, with this array here inside all passed by the value. So what you see is that inside these functions I'm going to print out every member of the array. That's just fine. Okay, now if I do something interesting, if I do this one, then actually after calling the function, your array will change into 34, 67 and 100. Okay, that's how it works. Okay, you just pass their address to your function. When you talk about functions, you also may want to specify some default parameters inside your function. Well, you may recall something that I have demonstrated to you before, like remember when I use seeing ignore, right? I can either use seeing ignore without parameters, I can also use seeing ignore with some parameters. Now when I'm using ignore without parameters, that means I'm using some default parameters. So here the language provides you a way to specify some default parameters value. Now one important note for you: every default parameter must be put on the right side. It's so obvious because if you put it somewhere in the middle, and then during the function call, if you ignore that parameters, then there is the ambiguous between the function call. It doesn't know, well, what value I should set for this parameter, because is it missing or is it not missing? Well, the compiler will confuse. So the language say, in order to avoid the confusions, it is better for you to put every parameters with default parameter on the right side. Okay, that's the rule. So here we go. This is another example. You see here that I have 3 parameters: length, width, and height inside the functions. All of them have default parameters 1, default value 1. So when I call this one with the parameters, then length will be 1, width will be 1, height will be 1. Okay, this equivalent to, well, the same function called with 1, 1, 1. The second one equivalent to 10, 1, 1, because the 2 other parameters were missing, so the default parameters value will be used. Alright, so I think this is clear right now. Now for function overloading, you may see something interesting. Let's say you have several ways to implement functions. Well, I may say you have a function to do one job, but that job operates in different kind of data. Then should I name the function in different way? Well, that won't be a wise decision, right? It is good for you to use the same name for that function, but different declarations, I think. Now let's say I have integer add integer. Okay, that's one function. Let's say I have another function called float add, also float. Now that makes sense because I don't want a function with a different name like add float or add double or so. I just want to use the same name. Okay, and the compiler allow this called overloaded function. Okay, you can write function with the same name, but remember it should have different parameter list. Okay, now how to do it? Because the compiler now consider the function name and parameter list as a whole. This one we call the function signature. Alright, so this concept is important. When you say function signature, you mean a name of your function and the parameter list. So if you have another function, let's say float add int. Well, for you it's alright because I have 2 different functions. No, the compiler say no, you can do that because the function on the left has the same signature as the function on the right. So I don't know what should I call. Let's say I have integer I equal add 1, 2. Then you may infer that this add is the first one. Let me name something 1, 2, 3. Is it 1 or 2? Well, you don't know. Really. If you call add 1, then it means the return type is integer, which would match with the data type of I. However, if you activate the add to, the function will return float. Maybe it doesn't match with the data type of I, but the compiler can cast that float into integer. And well, in the end, what you see is the return type doesn't make a big difference, but the signature is the important key point here. So you cannot do this, okay? In short, you cannot have two functions with the same signature. That is why you can have several functions with the same name, but they must have different signature. That's the rule of function overloading. And you will see some example. I don't think I need to explain here. It's pretty much clear to you. Well, on the class, I hope you have some questions, because this part is also interesting. It will help you to resolve some kind of concern about how to overload a function and how to avoid ambiguous in your programs. Okay. This slide just give you a very short note on function header in the 5. Okay. So like I told you before, you should separate the function definitions and function declaration from each other. Should not put them all together. So function declaration should be put in the header 5, and that's it. Okay, that's what I want to say here.